Here we go. So thank you everyone for joining us. My name is Emmett McGregor, joined here by Steve Furr, expert in the field of cannabis. We both have many years in the field. Steve, in particular, has raised millions of dollars in the hemp industry, as well as being active in the Washington state legal recreational cannabis industry. Thank you so much for joining us, Steve. Steve,
Thanks for having
full
me.
disclosure, is also our business development coordinator. So you may have contact with him if you reach out to us at that info@sciphysystems.com address. You may have the opportunity to ask Steve direct follow-up questions. So please do that. Today's session is all about the cost per unit manufactured. So what is the actual cost going into every gram or every kilo of oil, distillate, or other product that you might be manufacturing? And how do you bring those costs down? I mean, this is really the make or break on businesses in the term of years, or even in the short term of business survival, but also, most importantly, I guess from the eyes of the investor, increasing your profitability as a business once you're established. So really important issues we're going to be talking today. We're going to be taking a look at several different areas of activity that contribute to those costs. And we're also going to be diving into some specific equipment as examples for how the process and the equipment selection can impact those costs as well. So Steve, welcome on the show, and thanks for coming on.
Thank you. Thanks for having me, Emmett. You know, it might be a good idea before we get started to talk a little bit about what manufacturing costs are. Does that sound like a good place to start?
Absolutely.
Great. Well, in a basic sense, what you want to do is look at your costs in two different areas. One is going to be your fixed costs. These are things that don't change very much depending on how much volume you're producing. And a good example of that would be your rent. The second are your variable costs. And those are things that will change as your production output increases. And that could be something like solvent or electricity. And so you take those two, you put them together, and that produces your cost basis. And then you look at how many units you're producing. And you take your total costs and you divide it by the total amount of units that you're making, and you end up with what's called a per unit cost. Later today, we'll share with the folks a spreadsheet that we use to help people understand how these really work together. And we'll give people an opportunity to download that if they'd like that after the webinar.
Absolutely. So do stay posted for that. We have a lot of content going to the website. This content actually will only be available to those who are attending this seminar and contact us directly. So if you're interested in a more in-depth way to break down your own cost to manufacture, take a look at how to do cost comparisons, we would be glad to help you with that, both with materials and it should be mentioned that we do some business consulting on a limited basis as well. So if you're looking to add some expertise into your business and guide your business development, that's something you can speak to us about as well. So let's break down some of the main contributors to that cost to manufacture.
Sure.
We're talking about materials is probably the number one cost of anything right now, but it is one that we in our position as providers of equipment, as your position as an operator of a business where you're going to be focused on building up your operations and optimizing your operations cost, you're somewhat constrained by the market as far as your cost of materials with regards to your feedstock. Now, there's other materials to consider as well, though. Steve talked about solvent. Solvent, in many cases, is one of the largest cost contributors to operations, especially if you're using solvents like ethanol, which have a big tax implication and a relatively high turnover. So we're going to get into in-depth some strategies around materials, especially solvent as a material. Now let's look at the other key indicators. You want to walk through some of those other key contributors to cost, Steve?
Sure. Well, obviously solvent, and we'll talk a little bit about hydrocarbon type solvents and ethanol solvents later on. Power is a big factor. Um, um, the amount of shifts that you run, we'll find has a big impact on things. And it's funny, you look at other manufacturing industries, and there are very few manufacturers that plan their spreadsheets based on 5 days a week, 8 hours a day. And so we'll take a look at adding shifts. The next is labor. Labor is a huge cost, and that can be impacted by things like automation. Um, we'll also talk a little bit about throughput. The amount of volume that you actually put through a system is going to have a lot to do with your ultimate cost. And then finally, I think that the whole hemp and cannabis industry needs to take a more careful look at the waste stream and see it maybe not just as uh, a cost of doing business, but maybe even finding ways to monetize waste. So waste is another probably the final area to look at.
Yep, absolutely. And one piece that's not so apparent that we'll touch on somewhat is the how we consider the equipment itself to be a contributor to cost in areas like maintenance, depreciation, amortization. So we'll touch briefly on those. We're not going to go in depth into equipment finance in this presentation. It's something that we might consider for future presentations. So if that's something you'd like to learn more about in detail, please let us know. And we could possibly put together a dedicated episode just to that equipment finance piece. But just note that we may touch on those issues, but they're not going to be our main focus for this particular conversation. So, you mentioned in particular energy costs. And,
Mhm.
I want to bring up to start with talking about energy costs, what we find to be the biggest contributor to energy use in the overall system that processors use on an end-to-end basis. And that's typically two separate items, actually. Your winterization dewaxing process with very low temperatures being standard for more conventional type processes, and then solvent recovery. And those two, which involve mainly big temperature swings
Right.
and having to evaporate and do a phase change in the case of solvent recovery, are really big energy contributors. So maybe we can talk a little bit about solvent selection and how that guides some of that energy use considerations. And then maybe we can touch specifically on some new technological strategies for bringing that energy use down.
Well, the energy issue, of course, is dependent on the type of solvent that you're going to be using. And one of the examples that we'll bring up a little bit later is a hydrocarbon example. But as you mentioned, what contributes to the big energy cost is the huge swing difference or delta in needing to cool it, cool your oil, to winterize it, and then to heat it up to do recovery, especially with ethanol. And I think what we're seeing, Emmett, is really a sea change in the entire extraction industry. And there's a shift to finding more energy efficient ways of doing things. Some states like California are even mandating these changes. And technologically, one of the systems that we found that's very effective to do this with are the membrane-based recovery and dewaxing systems.
Yep. Yeah,
I don't know if you'd
absolutely.
like to
Yeah,
talk,
let's
get into membranes right now a little bit.
sure. Let's get into that, and we can talk a little bit more about how energy actually impacts the bottom line. You can see here. So this is a sort of a general outline of some of the items we're going to touch on. Let's just dive straight into membranes, and we touched on this spreadsheet here. But let's go into the membranes in depth, and maybe we'll come back to some of those other cost contributors once we talk in depth about the membranes. So going to the sort of conventional mode of operation, we'd say to do dewax, you're going to winterize, right? So you bring the temperature down, you're holding the solvent at a temperature, and then you're filtering out the solids, right, to be able to basically remove the undesirable waxes and fatty lipids from your oil in solution. Now, membranes have proven a big energy savings for that particular process, and as well as actually even a material and equipment savings as well. So you want to walk us through what this diagram here is showing as far as the wax side of this diagram?
Sure. Well, what the membranes do is allow for a separation of the fats and lipids without needing to cool the product. So we can take the oil into the membrane in an ambient temperature with the solvents, run it through, and remove the fats. The fats actually stay in the main channel, and then your oil is going to dissipate, and it's going to very quickly. That's an important thing to understand with membranes. They operate very quickly, remove the fats and lipids. And one important point also to make there about membrane technology is beyond just the speed and beyond just the ambient temperature and low energy, you can hook these systems directly up to your extractor. So it makes it much easier to create a end-to-end process that's continuous. You're not removing one batch and maybe manhandling a batch over to another station. These membrane systems are actually able to hook up directly to the extractor.
So actually, that touches on another key contributor to cost is the labor side, right? So this is going to
Right.
save energy because you don't have to do the big temperature swings. You're just using pressure to achieve the separation, but it also enables a continuous flow through type operation. And continuous flow through operations typically are going to let you bring your labor down. So by integrating this in a flow through basis with your extractor and with your downstream solvent recovery process, one operator can feasibly operate multiple stages in that process, and you're intensifying the process where your holding volumes are lower in the overall process because you're able to constantly feed through the system. And so that means that your total volume of solvent, one of those materials cost contributor, can actually come down, and the regulatory burden relating to that holding volume of solvent can also come down. So we really have to look at these sort of cost-based analyses from a multivariable type of analysis on each individual step, but then look holistically about how integrating each of the steps is going to impact the bottom line, especially with regards to labor, which later on we'll show labor is definitively one of the major cost contributors to operating one of these businesses. So
Right.
before we move on from same type of savings, continuous flow through, lower energy can be achieved based on the solvent recovery use of the same type of membrane systems with different membranes. So this is
Right.
really another very interesting cost reducing opportunity here, is in certain cases, especially when you're doing lower volumes, and you, instead of going continuous, you want to stay in a batch mode, at least in a short-term basis. It's feasible to use the same type of membrane equipment or even the same membrane unit with multiple uses on board, multiple types of housings on board, to do both the solvent recovery step as well as the dewaxing step. And again, reduce the energy by eliminating the need for big temperature swings, right? It's purely pressure driven, and it's just based on the specific membrane that you're using. So you can see here, very similar process between the two, between solvent recovery and dewax, but both of them have essentially the same benefit: continuous throughput, reduced energy usage, and because of the continuous type of operation and the level of basically steady state systems that are in place here, it's feasible to reduce the number of laborers, the number of technicians needed to operate the same throughput capacity of the system. So again, we're sort of tying together all those contributing factors to this technology selection. And one thing that's worth mentioning is, when we are talking about these sort of factors, these continuous throughput, the elimination of, and as much as possible, the manual labor steps needed to accomplish a given goal. These apply not only to the membrane technology, but also can apply to some other technologies. But for us, these membranes, which are available from multiple vendors, we happen to be a vendor for Molecular Forces LLC, but there's also several other options out there in the field. This is, in our mind now, and in our conversations with clients, gaining tons of traction because they've realized having to do manual batch style filtration of the waxes in particular, which is the bottleneck, it's costing them labor hours. It's giving them a headache because it often goes wrong, or there's inconsistencies in the way that the operation is handled, and therefore there is the need to troubleshoot on a frequent basis. And chillers are expensive to install, they're expensive to operate, and they have high maintenance costs. So when we look at materials, in this, you're going to have a chiller that's operating with just propylene glycol water solution, and all that chiller does is not to bring the temperature down, but just to maintain the temperature of operation. So you're talking about an order of magnitude less kilowatt capacity on this chiller that's going to be that's required for this operation. So there is some requirement for having a chiller. We're not going to say you're going to be able to eliminate that entirely, but order of magnitude less, and crucially, the temperature conveying fluid, the chiller fluid that you're using in a moderate temperature normal chiller that's not going to cryogenic temperatures versus a cryogenic chiller fluid. Right now, we've seen a spike in some of the pricing on some of that chiller fluid, and you're talking about the comparison of, maybe hundreds of dollars per quarter in terms of the moderate chiller capacity versus what, if you're doing an aggressive chiller maintenance schedule, could be thousands of dollars in chiller fluid from an ultra low chiller side. So in any process that you're doing, take a look not only at the cost of the equipment, but what's the cost in terms of materials, in terms of labor, and especially in terms of that maintenance turnover of materials that's going to go into operating that throughout the course of the year. And that is generically needs to be applied to every single process. And we find that it's often discounted when you're talking about solvent recovery and your DWACs in terms of the chillers that need to have fluid changed out, and your oil heaters that you might also have to change out your oil as well.
Emmett, you've hit on a couple other interesting points that are worth adding. One of the things that we've looked to these membranes to do is dual functions. And that's another great way to save money. I know a lot of, particularly ethanol extractors that come into the game say, geez, I didn't realize that, I need to buy all this equipment for extraction and then all this other equipment for post-processing. But to be able to buy one piece of equipment, and as you'd mentioned, we have a system that does dedicated dewaxing, and we have a system that does dedicated solvent recovery. But we found a way for lower volume processors to combine some of these functions. And for instance, in the dewaxing and the solvent recovery, where there's a manifold, you'll toggle that on and off, but it enables you to buy one piece of equipment to do that. The other point I want to make briefly is when you go to buy this equipment, you want to look for various forms of automation, even in the membrane systems, to be able to control through some type of a computer display your residency time, your pressures, your flow rates are going to let you really dial in your formula.
Right, and we do have versions of the membrane system, for example, that are manually operated based on a pneumatic drive, right? But we often suggest that people consider going to the electric version, which is slightly more expensive. But because you're able to do that push button control, you have a data readout in a central location, it actually allows your operators to come in, focus on one source of information, one point of control, adjust what needs to be adjusted, and then move on. Whereas with manual systems that are full manual, which again, we provide both. We provide manual systems and automated systems across the board for a lot of different processes. But that automation, the reason we suggest automation, and even if it's not automation, at least centralized control capabilities, is that that time that it takes to check the system, the time it takes to adjust the system, and then the time that it takes to be monitoring the system, how much time you have to commit as a laborer to monitoring the system, all of that time reduces the total number of functions that a laborer, a technician, or an operator, an extractor, whatever you want to call that labor position in your company, it reduces the total amount of functions that they can handle at a given time. So you're going to increase your labor pool, and that increases your bottom line costs. It's really something that it's worth taking the time to think through, and it's worth focusing on, because as we've run these numbers again and again, labor is definitively one of the most major contributing costs for almost all operators.
Emmett, I think we put I'm sorry, go on.
Oh, no, go ahead, Steve.
Well, I was going to suggest, I think we had a slide put together to show what a lower labor machine would do for you in terms of actual savings.
Okay, let's see here.
So the first slide I think we put together talks about energy. This slide right here talks about the solvent recovery system using a membrane and rototherm system, and kind of comparing that with falling film evaporators or rotovaps. And not just, I like to take the point with rotovaps to mention that these things break. And when they break, it creates problems. But aside from that, there's a huge, huge energy savings. And then the next slide, if you go forward, talks specifically about the hydrocarbon energy savings with our HVH 50 versus a leading competing model, where there are recovery systems right now in the hydrocarbon world that will let you save over 80% of your energy costs. It's a big number.
Yep, and to go back having trouble going back a slide here, but let me stop sharing and go back to talk about ethanol, which a lot of increasingly cannabis operators as well as hemp operators are starting to rely on ethanol more and more. And for us, basically, if you're not taking into consideration your energy costs as a part of that solvent decision that you're making, you're missing a major cost contributing factor. It's not just it's not just the type of equipment you use for the solvent recovery, but it's also the solvent basis itself. And to look at the use case specifically of ethanol for one moment before we move on to hydrocarbon, I do want to focus on this slide for just a minute. We've shown here several different energy type scenarios. And so you can see, even if you choose a falling film evaporator, there are probably 3 or 4 different ways you could hook that falling film evaporator and the following stage of for your finishing solvent recovery up. If you're going to do 100% electric and you're relying, especially if you're relying on a rotovap, your energy cost is 30 times what it could be by using a membrane system in conjunction with a continuous throughput solvent stripping device like a thin film evaporator, which we use the rototherm technology from Artisan Industries for that. You may find others in the field, but we are bringing a unique solution to the market. And it basically, when you look at a rotovap, the thing I want to emphasize here is looking at labor cost. Energy cost is a major contributor. We're talking about 30x the cost if you're in California or another area where energy is expensive. I mean, you're talking about thousands of dollars a year, possibly hundreds of thousands of dollars a year if you're a large operator, right? The energy cost is not to be considered a small contributor to your total bottom line, especially if you're in an ethanol type operation. But the rotovap, it's a batch system. You're combining a continuous batch type solvent recovery system in the falling film with a batch finishing step. And when you do that, you can't typically, your rotovap requires tending. It is a manual operation of loading it and unloading it typically, especially when you're going to these large bulb 50-liter type vessels. You're talking about a lot of manual input of labor of taking that bulb off, putting the bulbs back on. That in particular it takes a lot of labor because you can break those bulbs relatively easily. You have to have a very focused operator that has the right tools to do that. And you might be talking about even 15 minutes, maybe even 20 minutes of labor to just handle that appropriately and safely to mitigate the chance that you'll break something and take that whole part of the system down and out of operation. So that adds up shift on shift. If you look at the cost of labor being, anywhere depending regionally from $12 an hour up to $30 an hour for your lead techs, maybe even more depending on how specialized your operation is. It's nothing to sneer at talking about $3, maybe up to $5, even $10 an hour of labor sunk just because you've selected a batch operation instead of a continuous operation, right? And that adds up over time. I mean, again, we're talking about thousands of dollars a year of baseline cost in that selection.
And Emmett, don't forget cleaning. When you clean a membrane system, you run a little ethanol through it. When you have to clean a rotovap, it's a major undertaking.
Right. So downtime, cleaning is downtime, right? So if you can do an automated clean in place type solution where you're doing a throughput rinse of a set cleaning solution, could be your solvent, could be some additional type of clean in place solution that you work with a clean in place provider for. That can typically be done automatically. It can be done in a relatively short period of time, and it can be done relatively infrequently. If you're doing a continuous type operation where you have larger batches, you might be doing that cleaning, once every shift. You might be doing it once every week if you're in a hemp type scenario where your batches are thousands of pounds, right? And that means the larger your batch size can be, the smaller your downtime is going to be, the smaller your labor is going to be, and again, that's going to bring your cost per unit manufactured down substantially by percentage points here. We're talking about some.
Emmett, if we could, I think it'd be a great idea to transition to talk a little bit about labor.
Yep.
And one of the first things that's worth talking about is simply adding shifts. And if you keep all other costs constant,
Yep.
and you go from a single shift to 3 shifts, you have a savings of, again, over 30% on your per unit cost. So, when you look at the cost calculator spreadsheet that we use, instead of spending $145 per kilogram of output, you're only spending $90 per kilogram. And if you advance to the next slide briefly, this labor savings is specifically using a machine that's more automated, for instance, the HVH50, where you only have one, maybe 2 operators, one main operator and a helper running a machine, whereas a more typical extraction system is going to use 3 or 4 people running it. And again, you're talking about a savings of 35% per unit. And these things all start to add up.
Right, and we're talking about a larger scale extractor here. This is 50 pounds an hour. So this is for your larger operations. The smaller you get, the less labor you may have per operation, because maybe one operator can pack a column and run a more automated small system. But your total cost per unit sold, cost per unit manufactured, the smaller your system gets, the higher it's going to be, almost inevitably. So I did want to emphasize that this is for a larger operation. So when we're talking about 2 operators, 3 operators, 4 operators, I mean, I've seen hydrocarbon extraction systems where there's 6 or even 8 operators operating, racks of 10 columns where they're having to pack 2 at the same time all the time, and they're having to unrack and re-rack columns. I mean, you could, in those scenarios, you could easily have 6 or 8, but this 35% savings. This is a moderate use case scenario where we're talking about 2 operators versus 4 operators, I think. And that, so again, think about automation, think about integration, and always keep the number of operators that you're going to need in mind. So
Emmett, if I could add one thing, I don't know if you can go back one slide.
Yep.
There's something worth mentioning related to shift savings, and that is that the biggest driver in lowering costs by adding shifts is the fact that when you look at these cost spreadsheets, your fixed costs actually go down per unit when you start adding shifts. And I'll give you an example with rent. Let's say you're paying $10,000 a month for rent and your per unit cost is $60 per unit. You take the total units you're making and divide it by the amount of rent you're paying every month. And that number is 60 at one shift. Well, if you go to 3 shifts, suddenly that per unit cost of rent goes down to $15 per unit because your rent doesn't change when you add a second or third shift, but how it affects your per unit cost changes dramatically.
Yep, and we've seen many times operations that are thinking about going up in scale on their equipment to try and get more capacity when they're only running 1 shift on their existing equipment. And
Right.
Obviously, we love to see people trying to scale up their operations and their equipment, but our best advice is always, if you're not maximizing the output of your equipment, at least with doing 2 shifts a day, right? A graveyard
Right.
shift is kind of hard to get labor for a graveyard shift. We understand that can be difficult, and maybe you don't want your labor force to be doing that late night work. It can have an impact on safety in some cases as well. But at least running 2 shifts a day, if you're not doing that and you're trying to scale up your equipment, well, you should be planning your larger equipment to be running those 2 shifts as well. So make sure that you're taking this into consideration because, again, 34% difference in your labor costs per unit capacity, your cost per unit. That's big.
And Emmett, you bring up another important point we're touching on. Your 2 biggest fixed costs, your 2 largest fixed costs are generally your rent and your equipment depreciation. And in our cost models, we take the cost of the equipment. Let's say you spend $1 million for the sake of conversation, and you would divide that by its expected lifetime or how you would depreciate it in a tax scenario. So let's say you're going to depreciate it over 5 years. So you take that equipment and you divide it by 60 months, and then you divide it by the amount of hours that you're operational. And again, if you're operational at 3 shifts versus 1 shift, even the cost of your equipment starts to go down dramatically.
Right, and that's the apparent cost of equipment per unit manufactured. So that's the cost contributor of the depreciation and the amortization of any funding that you've gotten, like a loan on the equipment, over the number of units that you manufacture within a fiscal year, right? So that's
correct.
We're going to look at that from the perspective of running, your balance sheets and doing your tax reporting at the end of the year. You want maximum output for the given amount of depreciation in your equipment. Again, all we're saying here is when you're running your numbers, when you're planning your capacity, we highly suggest you're looking at 2 shifts a day as a starting point. Now, you don't have to do that when you open your doors. Maybe you don't have enough inventory dollars in hand to be able to bring in enough inventory to maintain 2 shifts when you open the business. But if that's the case, you need to plan to put aside capital to build that inventory fund so that you can get to the point where you can have 2 shifts a day running basically as soon as possible. It really has a major impact on your cost per unit manufactured and therefore your profitability.
Right. And really, Emmett, that brings us to the next huge cost driver, because all of these, of course, are interrelated. And I don't know if you can bring up that slide on throughput savings, but this is a significant driver. And when you start talking about scale, the example that we use here is a machine that does 50 pounds an hour and a machine that does 18 pounds an hour. And the difference, assuming all other costs are the same, is 36%. But if you take a look at the per unit cost difference, it's the difference between spending $143 to make a kilogram and $224. That's a big number. And the difference between those two is all profit.
Right. Absolutely. So this adds, it adds some complexity to the calculation. Obviously, as we were speaking before, we advise that you're planning on 2 shifts for the equipment that you buy, maximize the use case, maximize the use value of the equipment that you buy. But in planning your operations, put the spreadsheet together for your use case. We should emphasize this. This is going to be different for every business based on your bottom line costs, based on that rent rate, based on your electricity rate, based on the cost of labor. In your market, maybe some of those things are less expensive. So take a look and see here, okay, if I'm going to run 2 shifts and I have an extractor that does 30% more capacity, or 30% less capacity, or 1 shift doing 30% more capacity, and maybe I'm going to run 7 days, so I'm going to add 2 days onto my week instead of doubling the shift size. How's that going to impact my cost per unit manufactured? We can't say for every use case that this is going to be the case, but in general, when you compare apples to apples, the same business with the same number of people running the same number of shifts, a week, same number of hours a month of production, this is what we see. You're going to save substantial dollars per unit per unit manufactured, per kilo of oil manufactured, per pound manufactured, however you want to set that unit. It's going to be a substantial impact. So really the lesson here is drive towards scale if that fits your business model. If you're in a market where the market can tolerate more capacity, or where you, by bringing down your cost per unit capacity, you can increase your market share. If you can do that, go after it. Make it a high priority goal, but make sure that you're able to support that with your actual operations. Obviously, you want to make the decision based on how much inventory you can hold, what is the demand in your market. So don't overbuild capacity. There have been some companies, especially in the hemp field, where they over leveraged. They had too many capital expenses. They took too much debt on, and they weren't able to fill their capacity on a supply side or on a demand side. So you have to build appropriate for your market, run these numbers with realistic numbers on the outtake and on your ability to hold inventory capacity. But if at all possible, if you're out there and you're seeing that the market has more demand, we're seeing markets like Michigan, we're seeing markets like Chicago and Illinois, where New York is almost inevitably going to be one of these markets, where prices are high, the dispensaries can't get enough material to meet demand. Those types of market, focus on scale. Get bigger equipment, get more shifts in as quickly as you can to build your market share while maintaining your product quality. Obviously, quality is going to impact your bottom line because it's going to command what the price point that you can command for your product is. So we're not saying these are simple calculations, but they're calculations that you need to do for your business. Know what your costs are from day one. Know what your costs are from day -90, right? Plan 90 days before you open your doors. You should know what these costs are going to be, at least on projections, right? And obviously, we think that our viewers here are likely doing that. You're sophisticated operators, but it's worth reiterating how important weighing these factors are for your specific business. So,
Emmett, if I could just add one thing to throughput real quick, and that is to make sure you're assessing your bottlenecks. We find people undersize their solvent recovery quite a bit. One of the more classic areas that people undersize is their distillation capacity, where they're producing, say, 10 liters of crude an hour, but their distillation rig does 0.6 liters in an hour. And so it's important to assess those bottlenecks so that you're not choking your throughput capacity.
Great. All right. Well, let's move up. I understand my mic may have been a little bit quieter than intentional. So if you see me holding my mic, I'm just trying to give you the best that I can here. So let's take a look again at some of this CapEx consideration. We've touched on it quite a bit, um, and it definitely contributes on that throughput capacity question. Typically, we're as a rule of thumb, not always the case. There are some systems where your cost per unit capacity might be linear, but generally you get an economy of scale. There's an engineering rule of thumb that approximately you should save, you should pay 60% uh, of the price of 1 unit of capacity for the next doubling of capacity that you get, right? They call it, the zero point 0.6 rule. That's not going to be the same for every market. It's not going to be the same for every technology. So when we're looking here on cost per unit savings on hydrocarbon extractor, where this is a specialty market, there's a limited number of vendors, and the feature set is going to be extremely important in selecting the equipment and have a major impact in cost and safety. Don't get me started on safety. But you can see here that your cost per unit capacity, 44% reduction, right? Meaning it's approximately 60% uh, of, going up per unit capacity, you're getting about 60% savings, right? So this is about right on that rule of thumb, 40% savings, 60% price point. So uh, really important that you choose the scale of your business appropriately. And one thing I want to emphasize here, I know you've seen this, Steve. I know I've seen it. I've seen 10 small extractors in the same room, right?
Right.
That is extremely inefficient, right? You're not upping your per unit capacity uh, per unit operation at that point. You're just saying I'm going to do the same operation 10 times. That's meaning 10,
Right.
maybe 12, 10, maybe 20 operators for 10 extractors, maybe four operators per extractor. Your costs are going up astronomically when you could have instead taken that same capex and probably gotten not that 10 times one extractor worth of capacity, but maybe double that, maybe even more for that same amount of money. So
Right.
probably following the zero point 0.6 rule, you would have gotten 16 times that capacity for the same money. And not only for the same money up front, capex, of course, crucial consideration, but in terms of your operating costs, and that's over the lifetime of your equipment, that's going to far eclipse the capex in terms of the total dollars out of pocket and the total dollars that you're pulling away from profit. Um, so consolidate your extraction, consolidate your processes. Some redundancy is okay, but 10x redundancy, you should probably never see that. Even 5x redundancy, especially on extraction or some of these processes like desolventization, solvent recovery, or dewaxing. I mean, just the labor costs alone are gonna kill your bottom line.
And this concept of taking a machine, looking at the total cost, let's say the machine costs $500,000, and you divide the total output capacity, which in this case, we use an example of 50 pounds per hour, and you divide that by 500,000, and that's how you end up with that $10,000 number. That's a really smart way to compare equipment. And I see folks, we go to trade shows, we see them going looking at different extraction systems. And the way I look at it, the simplest way to compare price is to use this tool. What's the total cost of the machine? Let's assume we're comparing apples with apples. Let's make sure, let's say that, both Apple machines you're comparing are automated. They use the same solvents. They have the similar labor capacity. Let's assume all those things are the same. So now you just take a look at the total cost, divide it by the capacity, and that's where you end up with that figure. The important thing to understand with that number is that number, that ratio carries forth for the entire time you own the machine. So if you have one machine that's going to cost $10,000 per unit, and in this case, we have another machine that costs $18,000 per unit, it's almost twice as much. And that savings in terms of CapEx carries forth for the entire life of the machine.
Right. Yep. It's so important. I mean, yeah, shopping. Sometimes people just take get sold on features, right? They just or they get sold on the aesthetic, or they get sold on a narrative about the product. But at the end of the day, obviously, some of those things like service is really important. Reputation of the company is really important. Access to parts on an ongoing basis for maintenance is really important. But at the end of the day, if you take a look at all of those costs, if you're not making this decision your first and foremost decision, you know, what is the cost per unit output? What's the cost per unit capacity of extraction or of dewaxing or of solvent recovery as your first and foremost decision-making point uh, in terms of CapEx, right? I want to emphasize that this is within the framework of CapEx, then you're probably making a mistake. But even more important than that per unit capacity cost on CapEx is going to be your per unit capacity cost to manufacture, right? Which is what we are really talking about and focusing on today. And that is,
Right.
so I'm going to actually go all the way back to this spreadsheet here, right? So, when you're going shopping for equipment, yes, the CapEx, the price tag, very important, right? But if you look at these contributing costs here, do this when you're shopping. I mean, don't leave it until, okay, I picked my piece of equipment, now I get to calculate my costs, right? Take each one of these things and say, okay, well, this product is going to only use 30 amps, but that product over there, it uses 120 amps for the same capacity, right? That could be very well true for something like dewaxing, for example, or even for an extractor like the HVH 50. Take this, put a sheet together like this, get cut sheets from each of the companies that's providing the equipment, plug it into the spreadsheet and compare your projected cost per unit capacity. The variable cost is what's going to be impacted by your equipment, right? And plug it in, go line by line and compare. Now, one of those that I want to go to questions here. So please do start submitting questions. We're glad to answer any questions. I know we blasted through a lot of information today, so we're glad to hone in on any specific attribute that you all out there would like to talk about. But one of the ones that we've sort of harped on a little bit here that I think is worth really focusing in on for a moment is the solvent cost, because I think it's one of the most overlooked costs, especially for new operators that don't really understand some of the contributing costs. So let's take a look here and talk for a minute specifically about ethanol as a solvent. Ethanol as a solvent is expensive, period, right? They're mainly because of the taxation. You're looking at maybe up to 30, I'm seeing here $34 of ethanol once you include the disposal cost, maybe less than $30 per gallon of unit capacity. If you're buying in bulk, maybe you're getting that down to even $20 a gallon. But even so, when we look at solvent like butane, you're looking at probably at $6.50 or less per pound. So you might be at the $10, 10 to maybe a maximum of $15 a gallon, right? It's a little difficult comparing those solvents because they're typically sold as weight versus literage or versus liquid volume. But you can
Right.
see there, we're talking about an upfront cost of purchase. But then there's the other consideration that's more important even than your upfront cost of your solvent, and that is what is the use of value of the solvent. So spreading that gallon of solvent or that pound of solvent over the total number of times you can use it in a system before it's lost or before you have to dispose of it. So Steve, do you want to talk about reproofing in the case of ethanol for a moment and how
Sure.
that's impacting your costs?
Well, if anybody's worked with me in the hemp and ethanol world or in the cannabis side and they're using ethanol to make edible extracts, they'll hear my mantra about looking at their waste stream. And there's two big parts to it. One's your biomass and the other's your solvent. In the case of ethanol, I only can think of two processors in Colorado that are currently reproofing their ethanol. But the cost of having to buy, say, a gallon at $25 and then call a company like Safety Clean and have them cart away that ethanol at $7 a gallon is a very expensive cost, because then you have to go out and spend another $25 to replace the gallon you just threw away. So what this graph is showing right here is the difference in cost between constantly replacing this used ethanol that drops in proof and gathers water each time you use it in extraction versus running it through another type of membrane system that we use. It's actually a ceramic type of membrane, and the delta is huge. $34 a gallon to constantly buy it and replace it versus 49 cents a gallon. And I'm going to say that number again. We can reproof your ethanol for 49 cents a gallon. It's a huge difference. Huge difference.
I mean, I'd say this is a business make or break decision for ethanol processors. It's, we're talking CapEx costs here that are far less than you're likely to spend on solvent without reproofing in a year. I mean, just straightforward.
So Emmett, last night when I was doing some estimates on this, the return on investment with the capital expenditure on this reproofing rig, this is a rig that does 400 gallons in an hour, is about 7 months. And one of the things I say to folks in looking at this reproofing concept is this is equipment that you buy whether you own it or not. Meaning if you don't buy it and you're throwing away your ethanol, you're paying for the machine, but you don't own it every 7 months.
Right. And, we can talk a little bit about, there's an ethical implication to this as well. I mean, all that waste solvent, it's wasted production, it's wasted use value. Something has to be done with that solvent afterwards. It's likely to provide less value. In the worst case scenario, it's literally being thrown away and just having to be remanufactured. And the same goes with the energy. I mean, we should be focusing on waste savings, not only for the value, the actual dollars and cents, which is a huge motivator. I mean, we're talking, like, you can just see this here. We're literally talking about hundreds of thousands of dollars a year. I mean, bottom line, if you're a large scale hemp processor, hundreds of thousands of dollars a year on solvent. I mean, I've even seen millions of dollars a year on solvent is realistic. And if you're a smaller scale operator, you're still likely to approach that $100,000 plus range, even if you're at the smaller scale, if you're not reproofing your solvent or finding a way to bring that solvent cost down.
Well, Emmett, there's another important point, which is a lot of folks are constrained by the amount of gallons of solvent they can have on site. And so the ability to reproof your ethanol is going to let you stay within your permit limits. And there's another really important point. We've got a couple minutes here I want to try to get in. And that is that many states, Oregon, for instance, has the Energy Trust of Oregon. I think we found a program similar to this in every state. Michigan has a program that reimburses folks up to $2 million for one thing, to use equipment that's energy efficient. And when we start looking about, the real cost of doing this process, the carbon costs that that are being used in the solvents, in the heat and the cooling, the more we reduce our carbon footprint at each step, we're not just reducing costs, we're helping the planet. But the important point I want to add to that is that these state tax incentive and rebate programs don't just make a very small contribution. Some of these programs pay upwards of 70 to 100% of the cost of this equipment. It's a big number. And if you could bring a piece of equipment in, like a membrane system that saved you 35% and have the state or PUD pay for it, it goes to your bottom line pretty quick.
Absolutely, and it's key to emphasize here. Every state's different about what they will accept, but the general rule of thumb of what this looks like is you go through a plan. You say, okay, here's a standard type of piece of equipment that I would get that would be cheap, but it would be energy intensive. And here is an alternative piece of equipment that's more expensive, but it's going to save a lot of energy for the same amount of production. And what they're going to do is they're going to confirm, yes, okay, this is a viable way to save energy. And they're going to look at the total amount of energy saved over a given period. Could be 1 year, could be 5 years, 2 years. It varies based on the program. And they're going to say, okay, well, based on that amount of energy that you've saved and the difference in cost of the equipment, we're willing to give you this percentage of the purchase price of the equipment back to you as a tax incentive, or even in some cases, literally as a check, cash back.
Right. Yep.
So you're gonna have to check with your local programs, but this could be money in your pocket. But what it does take is a lot of advanced planning. I mean, you're going to need to
Yep.
don't start this at day one. Don't leave it until the end, because they have to do the review and give you the approval before the equipment is purchased or before the equipment lands. It sort of depends on your program. Oftentimes it's before you purchase the equipment though. So do this ahead of time. But when you're talking about what could be, in some cases, hundreds of thousands of dollars of savings for you, again, worth doing it, good for the planet, good for the bottom line, and oftentimes this equipment is going to have longer lifetime, lower maintenance, better features anyway. So you'll be getting a better user experience and better performance in addition to more sustainable practices and less energy costs. So really, really
Yep.
advisable to look at that.
That would be the final point to really hammer home, Emmett, is that we see a lot of folks, they don't know about the energy credit. They find out about it, and then they'll say something like, oh, we're going to plan this in another 6 months, but they want to do the lab in 9 months or a year. You really need to get started in that process a good 6 to 9 months before you're ready to make your buy, for sure.
So please contact us if you have any interest in finding out more about how we could work with you to leverage those programs, or we can refer you out to specialists in those fields. And thank everyone for coming. We are coming to the end here. Please reach out to info@sciphysystems.com if you want to learn more about what we've talked about today, or you want to receive some of these supporting materials, spreadsheets, etc., to help your business optimize your cost per unit manufactured. And of course, we're here for any equipment needs that you have, consulting needs, but really, we want to continue to give really valuable information to businesses to make your business viable, and more so to make your business as profitable as it can be. So please join us on our upcoming episodes in our season 2 of Plants to Plants. Stay posted to sciphysystems.com and at SciPhy on Instagram. So thank you everyone for joining us. We really appreciate it. And Steve, thanks for coming on. This has been a great presentation.
Great. Thank you, sir. Good luck. Bye.